Hello everybody, this is Todd Frazee, and this is your assignment to build a HSM Works Rotary Tool library. So this will be used for your milling operations. For reference, I've given you the stare-at drill chart if you need it, and we're going to build it from this list that I created from a spreadsheet, which is 21 tools for the S60 mill tool list. Okay, so rotary tools, they tend to go in what's called a carousel or tool magazine instead of a turret. The difference is on a lathe, the turret actually moves and holds the tools and during its cutting process, whereas the carousel or magazine is an automatic tool changer, so it holds the tools and changes them out with the spindle. The example here is an umbrella style, I believe, on a Haas machine. And rotary tools have to spin, so they all are centerline tools that spin along with the Z-axis, and they have different profiles. Okay, so we got a variety displayed here. So what you want to download, first thing you need to do is you need to download the tool list in PDF format so you can reference it. Yeah, but we also, once you've logged into the lab, upload your lathe library. The reason is, if we look at the tool list, I've got 3 tools that we'll be able to copy over from the tool library, from the lathe tool library, and use them in the mill library with one slight modification. Make sure you've uploaded your lathe tool library, and it'll save you the time of building those 3 tools. Hopefully this process goes much faster than the process for the lathe tooling, because we're going to use a common holder for all of these tools, so we don't have to deal with the technicalities behind that. We're going to use a ER32 collets, which should hold this entire range. ER16s might be more appropriate for the small diameter ones, but just to simplify things, we're going to use the ER32. And so every single one of these tools have the same holder. I've given you the part number, and in most cases the information on the spreadsheet will be enough to build a tool without actually going to the catalog page. So that's up to you. I'm going to build the first end mill, and then the first chamfer mill, and then the slot mill, and we already have the spot drill built. We'll probably build together the countersink and the corner rounding end mill. But the bulk of these, you already know how to make reamers, you already know how to make drills, so I don't need to have a tutorial walking through each one of those. Okay, so I'm going to only work on the things that are unique. You notice in the note column, I've also noted some material. So we've got one specific tool that's for steel, and that's the reason it has a 4-flute end mill on it instead of a 3-flute. So for the soft materials you use 2 to 3 flutes. For harder materials you use 4 flutes and up, depending on your application. Alright, let's get going. Without further ado, I'm going to go back to HSM. So again, if you haven't loaded the lathe tool library and you need a dummy solid part, you could have one of your parts open, but it doesn't matter as long as it's an empty solid model part that'll allow you to access the tool library. So you want to import your lathe tool library is the very first thing you want. Okay, and then you're going to select My Libraries. We're going to right click and we're going to create a new library, and we're going to call that one the S60-Mill Tools Library. Okay, so it's going to be all our rotary tools. Okay, so now let's look at what tools we can copy over. So there are 3 tools that I said we could copy from the spreadsheet. If we return to the spreadsheet, it was lathe tool 6, 10, and 11, which are a 36 drill and a 632 tap. we can copy the spot drill, and I believe if you hold the control key down, we can grab the tap and its tap drill. It should be the 107, number 36. We'll do copy, go to the mill tools, right click, paste, and it brought all the information over. Now there are two changes we need to make. Our tool magazine can easily hold 21 tools for the mill we're using. So we're going to use the tools that are on the chart. So we need to update these tools to be their corresponding tool numbers on our mill chart. And then there's a box we need to check that tells it it's a rotary tool. So if we go to spot drill, which one is that in our chart? It is tool number 6 in our mill. So we're going to right click on it and change its position to 6. And then we need to check this box that says live tool. On the lathe, if it's on center line, it's not a live tool, it's called a dead tool. And I'm going to select the live tool option, which tells it this is a rotary tool, so it'll output the codes for that. You don't have to put any other information in, any changes to use this particular tool in a milling application other than this live tool box. So we're going to hit OK. And then we're going to move on to the next one. So on our list, the 36 drill, that's the 107 diameter, was the number 10, is a number 10 drill. Okay, so we need to edit that one. And we're going to make it the number 10 drill. And we need to check live tool. Okay, now our tap is now orange because we've got a conflict. And on our list it was a number 11. Okay, we need to check that it's a live tool. Otherwise it won't put the spindle code in to spin it. So there we've got those three tools. It looks like I omitted the vendor and vendor information, which I should have put in there. But there you go. You've made your first 3 mill tools, and you haven't really had to do much. Okay, so we're going to hit OK, and we're going to go back to our tool library. And now we need to build tools 1 through 5. 7 through 9, and 12 through 21. Again, I'm only going to walk you through building one of each tool type, and you need to build out the rest on your part from the spreadsheet. Okay, so here we go. So we're going to go and look at our spreadsheet and see what our next tool is. So we're going to build this end mill here. It's a 3 foot 3/8 diameter. We've got a bunch of information here. So overall length's 2.5, shank diameter is 3/8, cutter diameter is 3/8, and the length it cuts half. If we can remember most of that, that's pretty much all we need. We need the brand AccuPro, and we'll want the URL. So let's go to the URL first and take a look at what this looks like. Alright, so it's a 3/8 end mill. It has 1/2 inch length of cut, but you notice it's got cutters on both ends. So I chose a more expensive end mill. It's $50, but it has 2 ends on it. So when one side's wore out, you just flip it over in the holder. And this end mill for a single-sided, it'd be way more than $25. So in the end, you're saving money if you're careful with handling the tools. If you're not careful with handling the cardboard tools and you chip off these ends, you've just wasted money. So anyway, we're going to take our URL information and we're going to go ahead and copy that now, and we'll go back to HSM, and we're going to do a new mill tool. Okay, it's going to be tool number 1, and our product ID is a URL we put in. And this was an AccuPro. Which is actually, I think, MSC's private label. Our description is 3/8 inch two flute FL end mill. And we'll leave the comment alone. Actually, I'm sorry, I made a mistake there. It's a 3 flute. Okay, we're going to go to the cutter. It's 0.375 in diameter. Okay, its length of cut was 0.5. Shank was 0.375. And our overall length, I don't remember what it was. Let's go back to our spreadsheet. Overall length is 2.5. And if it's not hassling us about the other numbers, why don't we just keep them where they're at? And it's a flat end mill. Shaft we'll leave alone. Holder, we're going to select from here, I think it was Tool, and we were using the ER32, the short gauge length. So let's just use this tool holder for basically everything in the milling. Okay, so we got that. We're not going to worry about the holder geometry. Feeds and speeds. I'm going to leave this alone. It's 3 flutes. It seems a little fast, but we'll just leave it at that. Okay. We'll hit OK. And now we have our first end mill. Okay, so pause the video here and repeat those steps. Doing the 4 flute end mill for its 1/4 inch and 1/8 inch. Use the data that's here. Change the number of flutes on that tab to the correct number of flutes. And we'll pick back up on the 3/8 diameter chamfer mill, which is tool number 4. Okay, so we're going to create the chamfer mill. So we're going to make a new mill tool, and we're going to go, and it's tool number 4. Okay, and it's a 3/8 chamfer mill, 3/8 by 90 degree chamfer mill. Okay, and the vendor was again AccuPro. And we're going to grab our ID information. Again, you got to make sure they all say live tool. Our cutter, we need to change the type to chamfer mill, which will allow us to put the tip on it. Now the default is for a chamfer mill that uses an insert. We're not doing that. So our diameter is 0.375. Our tip to diameter is going to be 0, which gives us a fine point. Okay, our edge angle, taper angle is 45, but included is 90. Okay, so it's 45 per side. And our flute length is going to be the half our diameter, so 0.375 divided by 2 gives us 0.875. Shaft diameter is 3/8. Our shoulder depth is not that critical because the diameter is the same as the milling cutter. You do want to put our overall length, which is 2.5. And you can mess with the shoulder length and the body length if you like. I'm just going to leave that at default. You're going to shaft, skip it, holder. Again, we're going to select that same mirror tool. It's a Cat 40 ER32 with an inch and 850 thousandths gauge length. Okay, holder geometry, don't care about. Feed rate, we'll leave that alone. And there we go. We've got tool number 4, which is our chamfer mill. You should have already built tool 2 and 3. Alright, so let's go on to our next unique tool in the library, which is our 1 1/4 inch diameter by 16th inch slot mill. Okay, so that's our slotting mill, and it's built by Onsrud. Let's go ahead and grab Onsrud's name there. It's a German company that make really good tools and very expensive drill bits. Very high performance though. Okay, so we're going to go new. We're going to put in the vendor is Onsrud. That's tool number 5. And our direct description is going to be a 1.25 by 0.0625 slot mill. Let's go back to our spreadsheet and we're going to look at what that cutter looks like. Okay, so it's a saw shape, has relief in the center, lots of teeth, so you need to go a little slower on the RPM. Get your 3/8 shank. Okay, so we need all this information, but let's grab our URL, put in our URL product ID. We're going to go cutter. We're going to change the type to a slot mill. So you should get a geometry shape that looks like this. Our diameter is 1.25. We have a 0 corner radius. We have a shaft diameter, according to our list, it's 1/2 inch. Okay, our flute length is 1 divided by 16. We're going to look back here and we have 1/2 inch shank, 16th. It looks like it's a continuous shank diameter. Interesting, it doesn't tell you how many teeth it is, so we can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 teeth if the drawing is correct, if the image is correct. Alright, so our overall length was 4 inches. Okay, set the shoulder length and the body length are the same, 2 inches. We have a shaft diameter of 1/2 inch. We've got a overall diameter of 1 1/4 inch. There's no corner radius on this milling cutter. It has an overall length of 4 inches, so that should cover it. Shaft, we're going to leave identical. Holder, we're going to again select the same mirror tool, ER32 with a 1.85 gauge length. We're going to holder geometry and feeds and speeds. Alright, so we counted 12 teeth on that thing. And I don't think we want to go 5,000 RPM with those 12 teeth. So we're going to say 2,000 by default. Now when we're cutting the steel, we need to go significantly slower on the feeds and the speeds than we do in the brass. Alright, that's tool number 5. Now let's go to, you imported the, should have imported the spot drill. I think you can do the drill and the reamer on your own. The tap drill and the 632 plug, they were imported from the other, and provided you check the box that said live tool, we should be good there. And we have a bunch of reamers and drill bits, which you have experience making. And so we're just going to skip on down to the corner rounding end mill and the countersink. So let's do tool number 20, which is the countersink. I'm going to go ahead and hit the product information so we can look at that. And so it's a solid carbide countersink, and it has a single flute, so it looks like a screw tip or drill tip. We'll grab our product information, and it's made by Hertel or Hertel. I'm not sure how it's pronounced. We're going to say new mill, general, and it's tool number 20, I believe. Live tool. And it's a countersink. It's a 3 divided by 8 inch sink. Put our vendor ID. Yep, wrong one. And the vendor was Hertel. 82 degree, which okay, by 82 degree countersink. The profile doesn't look like that because we haven't changed it on the next tab. Next tab, it defaults to flat end mill, and we're going to look for countersink. Okay, and we get a countersink shape. Okay, and our diameter is 0.375, and our tip to diameter is going to be 0, so that's a sharp point. This is actually 82 degrees. Okay, our shaft diameter is 0.375. Our shoulder length is academic, and our body length is somewhat academic because we don't have a difference in diameters. In reality, ours looks like the picture on the right, not one on the left. We could put some flute length in. I don't think it's that much. It's probably closer to half of 3/8. So we'll put 3/16. Even though I think that is most likely a little too much, but again, because the cutter diameter is the same as the cutter, there's no differentiation there. So let's put in the overall length, because we do want that to match. And the overall length of the countersink is 2.5 inches. Okay, that gives us a little better picture of what it's supposed to look like. Okay, shaft, leave alone. Holder, we're going to go and we're going to select that same merit tool that we have for all the others. Okay. Then we're going to go to holder geometry, skip all that. Here we are at feeds and speeds. The number of flutes is 1. It's a single flute. Yeah, I think actually going higher, say to 7,000 RPM, it would be appropriate with a single flute cutter. You need it spinning pretty quick. You could go faster than that if your machine's capable of it. My machine has an 8,000 RPM ceiling, so I don't like running it too long at that top end in the gearbox. Okay. With it all okay. And we've got tool 20, which is our 3/8 82 degree countersink. Alright, the last tool that I'm going to do in the tutorial, and it should be the last tutorial that you do, is this corner rounding end mill. Okay, made by Harvey Tool. They're another pretty reputable tool company. It's only used on 2 parts. It puts the 30 thousandths radius on the outside of the 2 post parts. So let's go ahead and take a look at what that tool looks like. And so it's got this stubby face looking thing, but the radius on it's 32nd. And if you have it set correctly, it does a really nice job of putting a corner round on it. If you go a little too deep, you're going to see a little step. And if the diameter's off, you get another step. But, okay, we're going to grab that product information. We're going to go back to our tool library, and we're going to make a new mill tool. Okay, and this is going to be tool 21. That's a carbide tool. Okay, live tool description, 3/8 by 0.03 corner rounding end mill. Okay, we got our product ID, and it's Harvey Tool Company. Here's our cutter. We're going to change the type. They're calling it a radius mill. I've always been told they're called corner rounding end mills, but that's okay. We'll call it a radius mill. A little more specific. So our radius is 0.03 for 30 thousandths. It looks like we need to look up the diameter of the actual tip of the corner rounding end mill. So let's see if the information on the specs tell you that. So the tip diameter is actually 1/4 of an inch. 0.25. So we have a 30 thousandths flute length. Our shoulder length should be the same. Now, okay, so for this cutter, we've got a shoulder length of 30 thousandths. We have a flute length of 30 thousandths because it doesn't really have a flute beyond that. Corner radius of 30 thousandths with a nominal tip diameter of 1/4 of an inch. Shank diameter is 3/8, and a body length of 1.5 inches with an overall length of 2.5 inches. Alright, so we're going to move on to the shaft. I'm going to leave that all alone. We're going to select our Ameritool tool holder, Euro 32 with an 1.8" gauge length. Holder geometry stays the same, feeds and speeds. This is a 4 flute end mill. Yeah, we're only going to be cutting steel with this, so I'm thinking 2,000 RPM with that sucker. And let's say okay. Alright, so you have all the tools to make all the tool libraries. So you have a bunch of drill bits and reamers to make. So when you're all said and done, you should have a total of 21 tools, including the ones we did in this tutorial. Alright, thanks a lot, and I will catch you on the next one.